Purdue University engineers have created white paint that can keep surfaces up to 18 degrees Fahrenheit cooler than their ambient surroundings, almost like a refrigerator does, but without consuming energy. According to the researchers, the paint would replace the need for air conditioning by absorbing nearly no solar energy and sending heat away from the building. Without the building heating up, air conditioning wouldn't have to kick on. The paint would not only send heat away from a surface but also away from Earth into deep space where heat travels indefinitely at the speed of light. This way, heat doesn't get trapped within the atmosphere and contribute to global warming. Earth's surface would actually get cooler with this technology if the paint were applied to a variety of surfaces, including roads, rooftops, and cars all over the world. In a paper published in the journal Cell Reports Physical Science, the researchers showed that compared with commercial white paint, the paint that they developed can maintain a lower temperature under direct sunlight and reflect more ultraviolet rays. Their proof is infrared camera images taken of the two paints in rooftop experiments. Commercial heat rejecting paints currently on the market reflect only 80 to 90% of sunlight and cannot achieve temperatures below their surroundings. The white paint that Purdue researchers created reflects 95.5% of the sunlight and efficiently radiates infrared heat. Developing this paint formulation wasn't easy. The 6-year study builds on attempts going back to the 1970s to develop radiative cooling paint as a feasible alternative to traditional air conditioners. The researchers considered over 100 different material combinations, narrowed them down to 10 and tested about 50 different formulations for each material. They landed on a formulation made of calcium carbonate, an earth-abundant compound commonly found in rocks and seashells. This compound, used as the paint's filler, allowed the formulation to behave essentially the same as commercial white paint but with greatly enhanced cooling properties. These calcium carbonate fillers absorb almost no ultraviolet rays due to a so-called large band gap, a result of their atomic structure. They also have a high concentration of particles that are different sizes, allowing the paint to scatter a wider range of wavelengths. According to the researchers' cost estimates, this paint would be both cheaper to produce than its commercial alternative and could save about $1 per day that would have been spent on air conditioning for a one-story house of approximately 1076 square feet. Cutting down on air conditioning also means using less energy produced by coal, which could lead to reduced carbon dioxide emissions. The researchers are working on developing other paint colors that could have cooling benefits. The team filed an international patent application on this paint formulation.